Okay, so this is a 2.0 micro coil. I have built a new probe for this test and tested it again in the ice water, and it came out at 0. So whatever reading is over here on this meter, you can take directly to the this chart here that I showed you a link to, and you will be able to compare that with known cross sections of voltage for temperature conversion. So let's go ahead and take a look here. The coil, I have a just a standard drinking straw that I've cut to make it a little bit shorter. I'm going to blow directly on the coil with the drinking straw. I think this might help simulate, an actual airflow hole, like what actually occurs in like a dripping atomizer. Because when I'm just blowing on it with my mouth, it's kind of like a real direct, or it's kind of a real indirect sort of airflow versus the straw, which is going to allow me to really pinpoint airflow, which is exactly what would happen in an RDA. So let's go ahead and check voltage on the meter, or check voltage on the mod here. This 2.0 coil, I believe we're going to fire this thing at 3.3 volts. Yep, 3.3 volts. And just leads are real delicate there. Meter's still reading 0. Okay, alright, so let's go ahead and do this. So at that point, it's starting. At that point, it's starting to look a little bit dry, not burned by any stretch of the imagination, but just a little bit dry. So we're gonna go ahead and add some more e-liquid to it there, and try it again here in a second. Maybe do 2 or 3 tests here just to see what it looks like. And you can see that the cold e-liquid has really lowered the temperature. Just from messing around with RDAs, though, I can tell you that the e-liquid that's down there inside the juice well is probably not that cold as compared to the 60 degrees it is in this room right now. Just having spilled it on myself, burned myself, done a lot of great things with RDAs. So let's go ahead and try to see what kind of temp we can get out of this thing here. Interesting. So you have to remember that the probe is embedded into the core. That's running directly into the center of the wick there. So that's kind of interesting that you get that kind of 6 something. I don't know exactly. I'll have to look at the footage because I'm trying to concentrate on getting that airflow directly on the coil. But that's kind of interesting that you end up getting that. So just to give you an idea, 3.3 volts on a 2 ohm coil like this, it doesn't make much vapor. Somebody that was running this would think, oh yeah, dripping atomizer, 2 ohm coil, I can probably run that at 4 volts, and we'll try that. We'll try that right now. Why not? Let's see here. Wake it up. And 3.3, and we'll go up to 4. Alright, let's try that. So here we go, 4 volts. Oh, I should probably, before I burn the wick up, I should probably put some more e-liquid on it here. Just to make sure. You know, I mean, it looks saturated, but we're just going to go with the, whatever the most, e-liquid this thing wants to hold until it's kind of pooling down towards the bottom of it. And that's what we'll go with, because that would be like, it's sitting in a juice well. Alright, here we go. Interesting. So when I'm doing that, I'm trying to remember to count to about 4 or 5, because that's about what for an RDA like this one, I would probably go, 4 or 5 second, big lung inhalations on it to, really get that big vapor cloud. So I'm not entirely sure what we came out at there, but I mean, as you can see, let me grab a flashlight here so we can get a, it doesn't look burned at all, really. It doesn't, there's a little bit, I can see a tiny bit of like maybe a little bit of carbon on there. I don't know exactly. It's black. Those little black dots you can see on the coil might have been some, I was careful to try to keep the wick off the coil, but you never know with these things. It does look like the coil is holding together. Doesn't look like there's anything really popping out of it. Let's see what we got here. Yeah, alright. So let's go ahead and do one more, and then we will I will show you if I have time here. I don't know. You know what? I'll make a new video that explains how to interpret the data. See you later.